recording first. Before we get going into today, so we have a test back. You should have the test back from yesterday. Everyone did very, very well. Here is the way it all laid out. So as you know, I have a second period, a fifth period, a sixth period, and a seventh period algebra class. And y'all's average? Fifth? Well, do you see numbers going up? Okay, Captain Obvious. So if you'll just be patient, thank you. 92.05 and 90.05. Y'all are the wieners. Congratulations. Well, the pride of knowing you're the best. The pride of knowing you're the best, at least for what, 4 days? Because the district test is on Tuesday. But really, y'all did very, very well. And I think most of you will find as you're looking through the test that the ones who didn't get a 100, you gave away some points, right? So all it kind of does is it kind of serves as a reminder to just slow it down a little bit, right? Slow it down a little bit, especially on Tuesday, because it's really, really easy to mislead you. We're only going to add in systems into the test on Tuesday. Everything else is stuff you've already had. So let's go this. Is the point -1, 3 a solution to the inequality x minus y is less than -6? Kaylee, what did you find? How did you solve it first? Okay, slope-intercept form. So we subtract x from both sides. We end up with -y is less than -x minus 6. And then? Very good. You're going to divide by -1 everything. And when that happens, you have to remember to flip it, which gives you y is greater than x plus 6. And then once you have y equals x plus 6, the y-intercept is 6. The slope is 1, which means what about that line? It's an increasing line, right? So you have this. I'll just draw. You're going to draw using a straight edge. Right, Carden? Thank you. And you're going to dash it. Why did I dash it? Yes. And where do I shade it? Y above. Because it says y is greater than. Guys, make sure that is something you get. You're just going to shade above. Then we simply graph the point, -1, 3. Is it a solution? It is not a solution. It is not a solution. How do we solve it algebraically? All we got to do is plug them in. We just need to be careful to make sure that when we do it, it's into the original, x minus y is less than -6. When we talk about numbers being less than a negative number, what do we kind of have to think about? What numbers are less than -6? Avery? Yeah. Everything to the left of it on a number line. -7, -8, etc. So let's plug them in. We have x minus y. What's -1 minus 3? -4 is less than -6, which is not true. Nay, nay, said the horse. Okay? Any questions on that? How do we graph this inequality? Pardon? Perfect. It is, and say again, at -5. It is a horizontal line at -5. Is it solid or is it dashed? It is dashed. This is your inequality. I know. Where do we shade it? Above. Some of you missed that on that test where it gave you the x is greater than -3 or something, and you shaded the wrong side. You've got to think about where the numbers are that are greater than -5, and they are all up here. Okay? All of these numbers are greater than -5 from a y standpoint. So then we graph our point. 0, -2. Is it part of the solution? It obviously is. When we plug it in, what's the only one we plug in? The y value, which is -2, and -2 is indeed greater than -5. It is, so it is. Any questions on all that fun stuff? All right, cool. So Today we're going to learn about systems of inequalities, and here's what I want you to do. Your rankings again. Okay, with a partner. Okay, if you're in a 3 group, you can use all 3. If you're in a 4 group, pick 1 partner. With a partner, you have 5 minutes to complete the paper that says Investigating Systems of Inequalities. Investigating Systems of Inequalities. And if you want to know what to do, they have these nouns and verbs that will instruct you under the directions. Ready, set, go. Guess where I'll pause this. All right, here we go. So let's talk about this. This is the way you're going to check your answer. I put the ordered pairs in the proper place. Inequality 1. Did everybody figure out which one? Well, they're already marked for inequality 1 and inequality 2, right? Where would be the both section? Where would be the both section, Carden? Yeah, the darkest part, because you have 2 overlaying shaded parts. So this is the both area. This is the neither area. This is the only 2 section. This is the only 1 section. So go through and take a look at your ordered pairs and see if there's one where you're not sure why I placed it in the section I said it should be placed in. For section 1, I have 0, -3. So here, and I have -4, -4, which is right here. That's section 1. For inequality 2, I have 0, 4, which is here. I have 2, 2, which is here. Now, I put a star around this one because it's at -1, +2. -1, +2. Why do you think I put stars around that? Joey? The dotted line represents inequality number 1. But it can't be part of both because it's on the dashed line. So it is not part of inequality number 1. It's only part of inequality 2. And I was listening to you guys have conversations about that where you're like, it's on the line. And they were like, yeah, but it's a dashed line. You have to keep that in mind when you're talking about whether it's a solution to an inequality. Okay? Now, if I wanted to write inequality 1, how could I write the linear inequality for number 1? Where would I begin, Madison? Okay, and the y-intercept is? The y-intercept is +1, b equals 1, and what's the slope? The slope is -1. Is it shaded above or below that line? It is shaded below the line. Does everyone see on this dotted line that it is shaded below the line? Therefore, we would write y is less than -x or -1x plus 1, right? Brady, what did you get for inequality number 2, please? 1/2 x minus 1. So we got a slope of 1/2, which is correct, up 1 over 2. He got a y-intercept of that. Carden, what did he miss? It's a solid line, so you would include the equal to. Be very careful. We're really having to consider a whole lot of things when you're dealing with linear inequalities. Slope, intercept, shade above, shade below, and dashed or solid. Remember on all your worksheets I had those 4 things that I would make you do before you did a graph or whatever? Those are your 4 checklist items. Slope, intercept, shade above or below, dashed or solid. And that will help you construct that linear inequality. Okay? Where do you think -15 and 18 would be? Where do you think -15, +18, that ordered pair would be? And I want an explanation. Carden? Perfect. Do not guess based off what you think you see. Now, if you have the graph and it's on the graph, graph it. No problem. But if it's somewhere off the graph, which that definitely is, You solve it algebraically by plugging it into the inequalities and seeing which ones work. If both work, then both work. If only one works, then only one works. Joey? Okay. I would just be cautious about manipulating graphs if it's not on the graph. Okay? Any questions on that? All right, so today we're going to do systems of inequalities. What is a system? What is a system of linear equations? Two or more lines. What do you think a system of inequality is? Two or more inequalities. So we just have to graph them and then shade them. You just have to be cautious about the manner by which you shade them. I will tell you, I get the benefit on a smartboard of having a yellow highlighter and a blue highlighter. How will I tell where they overlap? It's green. Welcome to science. Okay? You don't get that benefit. I will tell you, some kids shade lightly and then darkly shade where they overlap. Some kids will shade and put like a big S in the section where they overlap. Some kids use diagonal lines. Some kids will shade one area like this, and then they will shade the other area like this so they can see where they overlap. I don't care which ones you do. I would not choose vertical and horizontal lines, though, to do the lines. I've had kids do that. That's not smart. Why would that not be smart on a coordinate grid? Because there are a whole lot of vertical and horizontal lines. Just saying. Okay? So here we go. Is this in slope-intercept form? Yay! So I start at 1, and I'm going to go down 1 over 2, down 1 over 2, and then I'm going to go backwards just to make sure I'm good. Is that a solid or a dashed line? Solid. So I connect them with a straight edge. After all that, and I said that in every class period, I had kids who did not do a straight edge. Okay? Should I shade above or below this guy? Below. Very good. So I'm going to shade below the line. Nice and neat. By the way, I have some kids who they finally get to break out their matte pencils in this unit. Feel free to break out your colored pencils if you want to. Some kids like to do that. Okay? Because blue and yellow make green, or red and yellow make orange, or any, yes. Okay, now I got this dude. What did we learn on the test? How do we graph a line in terms of x? What does it look like? It looks vertical. And where would I draw it? At 1. So I have 1. Is it dashed or solid? This one is solid because it includes the equal to. So here is my line. X equals 1, where would I shade x is less than or equal to that line? To the, whoa, to the left, to the left. Go off, Beyonce. Done. Now, my solution area is right here. This is my solution area. Okay? That's where I would put my S. If it says label it with an S, please go ahead and do that. Ooh, that looks exciting. Woohoo! Okay, so let's start with the first one. How do I graph one where there is no x term, it's in terms of y? Horizontally, right? So I go to where y is 2, which is right here, and I draw a horizontal solid line. I draw a horizontal solid line. Where would I shade that? I shade it below. Okay, so let me go ahead and shade that below. Now let's go to this dude. Is it in slope-intercept form? Not really, but you can probably graph from this, right? Because where do we always find the slope? In front of the x guy. So the slope is what? -1, and the y-intercept is 2. The y-intercept is 2. So I would start at the y-intercept, which is 2, and I would go down 1 over 1 to draw this line. Is this one solid or dashed? It is dashed. So, I hate these. Dash dash, 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 dash. It's really more dotted, but whatever. Everyone with me so far on how I do this? Am I going to shade above or below this line? Above, it's y is greater than. So let me change my highlighter color to blue, and I'm going to shade above the diagonal line. It's getting already a little bit complicated, right? So I have to be very neat. This is why straight edges are critically important. And now we get to my last guy. I will graph that one in red. What is the slope and what is the y-intercept of our last line? There's no such thing as the slope of x. 1 and negative 2. Very good. So I go to negative 2, and I'm going to go up 1 over 1. Dashed or solid? Very good. Now, am I graphing above or below that? Above. So I want you just to look really quickly. So far, our overlap area is right here, right? The green. Now we just added the red line, and we're going to shade above it, which makes the solution area this very small little triangle right here. That is my solution area right in here. What I have to be careful about is remembering which lines are solid, which ones are dashed. If it's inside the little triangle area, it doesn't really matter, right? But if it's on a line, I better remember which of those lines is solid and which one's dashed. That is my solution area. Any questions on that? I can add as many lines as I want to. It's a system. A system does not have to be only 2 lines. It can be 3 lines or 4 lines or 5 lines. Yeah, it could be. Okay, so you have to just take your time and think about it as you go. Now, get your calculators. Oh, you people. On the, let's see, Unit 6, Day 9 warm-up. Be sure you have a calculator. Gosh. Yes, there's reading and math. I know, it's shocking. Go ahead and 2 plus 712 to clear. Now I'm going to show you something. You may enter in inequalities in y equals. You can enter inequalities. Now, I want to talk to you about a limitation before I even get going. 2 plus 712. When you hit y equals, what do you see all the way down the left-hand side of the screen? Y's. What do you not see? You can never graph a line in terms of x. You cannot graph a vertical line. So if you ever have that, you're out of luck. That's why we teach you without the calculator anyway. You should know how to do it no matter what. So here's what I would like for you to do, okay? If you arrow all the way to the left of the y sign, see where it's blinking to the left of the y sign? Got it? Anybody not have a little blinking cursor to the left of the y? You got it, Cade? Okay. Now, here's what I want you to do. I want you to hit enter. And what you'll see is it starts to change. It first becomes kind of a bold line, and then you see a blinking triangle that looks like this. Right? If you have arrowed over all the way to the left, where it's blinking to the left of the y, dude, you're arrowing right, baby. Go to the left. Oh my gosh, you're killing me. Yeah, your other left. And hit enter until you see this blinking. If you now go back to the right where the information is, and you enter in an equation, and you hit graph, it will shade above the line. So here, let's try it. So everyone has that little blinking triangle, right? Go back to the right of the equal sign, and I want you to type in negative 2x plus 3. Negative 2x plus 3. Negative 2x plus 3. The x is to the right of the alpha sign. That's your x value. And then I want you to hit the graph button. Negative 2x plus 3. Hit graph and just watch. Did it not work? Who did it not work for? And I can help you walk through it. It's not, but you didn't do the thing. You arrow to the left, hit enter until you see that triangle. Now hit graph. Got it, Carden? Yes, now hit graph. Okay. Okay, now good. Go back to y equals arrow all the way to the left. Hit enter. Hit enter again. See the triangle blinking? Now hit graph again. Now what you should see is it graphs the inequality. Did it not work for anybody? Okay, then hit y equals, arrow all the way to the left, all the way to the left. Right, now hit enter. Hit enter again. Now do you see the blinking triangle that I'm showing? Now hit graph again. So now hear this. Go back to y equals. Go down to the next line, which is y2. Go arrow all the way to the left again. Hit enter, but this time I want you to see a different triangle. I want you to see the less than triangle, which will look like this. You see how it's shaded below the line? Now go back over to the right of the equal sign, and let's type in x minus 5, which is a slope of 1 and a y-intercept of negative 5. And then hit graph again. Oh, hit y equals. Go down to the next line. Go all the way to the left. Hit enter until you see the opposite triangle. Good. Now go back to the right of the equal sign and type in x minus 5. Good. Minus 5. Now hit graph. So, now I want to caution you about something. Two things, then we'll get on our classwork homework. You cannot differentiate between dashed or solid lines. It only shades areas. Okay? So, it's only shading above the line, so this is a y is greater than, or y is greater than or equal to, or it's shading below the line, which means y is less than, or y is less than or equal to. It does not differentiate between a dashed line and a solid line. It will not graph in terms of x, so it has limitations. My personal opinion, my personal opinion is it's better just to do it. Now, if you get to the end of a test and you have time and you want to check to make sure you shaded the right area, plug them in, okay? Do not use your calculators to find answers, ever. Not at this school, okay? You find your answers, you let the calculators check them. Got it? Any questions? Classwork, homework, go.